Hi, welcome back to networking. Today we're looking at bandwidth, throughput, and how we measure that kind of stuff. So let's go ahead and get started. We're going to look at Python, curl, iPerf, and a couple of other tools that we can use right here. So I'm going to bring this up right here and enlarge it a little bit to give us kind of an idea of what we're doing. So first of all, we have iPerf, and iPerf is a great testing utility, and it lets you know what the throughput will be between two systems. Now, for those of you, one of you is going to be a server first and then a client. Then we'll just flip it right over, and you'll be the server client. So no biggie. I'm going to be using 10.10.10.115 with you, so I'll be the server first, and we'll see it on the screen when you do it as a client. So very first thing is let's go ahead, and I'm going to run an example on the board. This is with iPerf. So iPerf, I can just go up here and type iPerf-fm-i1-s. What that stands for is format in megabits, not megabytes, but megabits. Interval, 1 second, so show the output for every 1 second. And S, operate as a server. Now, what you're going to type is iPerf, and this is only one computer at this point, not everybody, so you can get your servers if you want to figure out who's a server in here. You can go ahead and do that. So on the client side, you type iPerf-fm-i1-c, and then your server IP address, which is going to be 10.10.10.115 for only you. Everybody else, it's your partner's IP. So, and as soon as you're ready, go ahead and press enter, and go ahead and let's look at the throughput that we're getting. Excellent throughput right there. We have that 933 megabits per second coming across, and it keeps going dropping down, and we ended up with 934. So remember when we talked about 40% is the maximum efficiency we can get on a hub, unless you just have two computers connected. But 40% is what we look for in a hub. So on a switch, we're looking at better than 80% efficiency. 80% is where we monitor things, so we look at 80%, and that way we can under-promise and over-deliver, because any properly configured network should give you better than 80% on your switch. Having said that, when you start increasing traffic on the network, it is going to degrade the performance, so you have to watch out for that. So we do 40-80 when we do our times. We give it a 40%, 40% speed, which is going to be efficiency, and an 80% efficiency rate whenever we predict how long something will take. Now, the way we have this network set up is we've got some computers that plug into a one switch, so we have 10 computers on one switch. We have 6 computers on another switch. That switch actually plugs into the first switch, which goes over to the firewall port, which gives us 16 computers going into one port on the firewall. So you actually have 16 computers hitting that one port, and that's going to be our bottleneck right there. And then on the back section right there, we have 8 computers going into that one port in the firewall, and that's, of course, going to be the bottleneck there. And if you go out to the internet, then there's only one port going to the internet, and so that'll be the bottleneck going out to the internet. You can see how we get these computers, and we narrow it down, narrow it down, narrow it down, and that's where you get bottlenecks whenever you're going out through a network. Okay, so in this case, we got this 934 megabits per second. Now, I want everybody to type this right here, and if you've tried it back and forth now, everybody try your reverse rolls? Good. Now I want everybody, and I'm going to count down. I'm going to do 1, 2, 3, or I'm going to count up. 1, 2, 3, and then press enter, okay? So over here, we're going to see, I'll put a line here. We're going to see how when all 5 of us hit the network, what is the impact to our network performance? Okay, now, for the 2 of you that are sitting right here on this network, you've got like direct connectivity. You know, you're coming straight here. You are hitting that switch, which that switch then comes over to this switch. Closer. For those of you over there, you're going through the firewall, through the wall, back over through this switch in. So, a little bit there. But does everybody have this typed for the client address? iPerf-fm-i1-c 10.10.10.115? Everybody, pretty much? Okay. We'll give it a sec there. And while we're typing that in, we can look at this. It gives us a rating. So you see this 1 to 2 seconds, 2 to 3, 3 to 4. And then at the very bottom it says 0 to 10 seconds. This gives you your average throughput. So your average speed was 934 megabits per second. Now, one of the things that might be a little misleading in iPerf, which iPerf is a great tool, is a fantastic tool. One of the things that might be a little misleading with iPerf is iPerf could be using an algorithm to transfer traffic back and forth, so it is absolutely purely expecting what it receives from the client on the server. There's no, oh, I didn't expect that traffic. It's getting exactly what it expected. And so there could be some area for that to not quite go well. All right, so let's get ready, and we're all going to press enter at the same time. Let me make sure that nobody's pressed enter yet. So let's do this. Okay, get ready. When I say 1, 2, 3, everybody press enter. Okay, 1, 2, 3, enter. Okay, now if you look at the throughput, wow, what happened to us here? So if we look at this right here, we started up here at the 935, and we're ending up at 144. We can go through and just look at the 0 to 10s. And the 0 to 10 seconds, 181, 0 to 10 seconds, 202, 0 to 10 seconds, 188. Do you see how big of an impact that made? Yeah, that's huge, right? That's huge. Well, that's using iPerf. Let's go ahead and try it with some files that are already on your PCs. So the way we're going to do that is, this is iPerf, which is an excellent tool, but we may not have that. Maybe we're working with Python. So on your computer, if you do an LL 1 star, you should see that you have a gig file, a 100 meg file, and a 10 meg file. We're only going to use that gig file. And by the way, this is in the temp directory, so be sure you're in /tmp. And look in that /tmp or the temp directory there. Okay. And you look at the temp directory, and you can see that we've got that gig, 100 meg, and 10. In your temp directory, you do a cd/temp like that. Yep, cd /temp. All right. And then you do the LL1 star, and you can see the files there. All right, now that you see that, we're going to create a Python server right there. So for those of you running the server or the client, it doesn't matter. You can all start the server at the same time, so you can all make it run. It's not going to impact you. You do a Python 3 -m http.server and just do 8080. So now you've got a server running on port 8080. When we curl a file, when we curl download a file, it's going to give us like the amount of time it's going to take and other factors like that. So it's going to tell us how long things are going to take. And this is the last practical way we're going to do it. After this, we're going to start looking at theoretical. So what's the theoretical amount of time it would take to download a certain file size? And I think that you're going to find that it's going to be really close, very accurate. So over here, we've got this Python 3 web server. On the other system, on the client computer now, you're going to do a curl 10.10.10 your partner's IP :8080 /1000 MB, and then output that to dev null. And when you do that, go ahead and press enter whenever you're ready, as long as you're doing it against your partner's PC, and then go ahead and flip-flop and do it to the other PC. And you're both running the web server already, so you just, one person runs the curl, then the other person runs the curl. So. Did you type that? You need to run that right there. I'll see it pop up here on my system as soon as you run it. Okay, now if you'll run the download, do the curl simultaneously for you and your partner. So both of you do the curl at the same time and look at the bandwidth decline that you experience on a single pipe. Because you should be getting, everybody is getting like around 900 something, right? Or you're getting around 880. Oh, and curl gives you the speed in megabytes, not megabits. So you need to multiply that by 8. Multiply the megabytes by 8. That'll give you bits. I just ran it, but this is on my own system, so this is like useless. Yep. Do it at the same time. See how your throughput is impacted. Yeah, you're both still have the server running. Yep. And you're both typing the curl command simultaneously, running it, and you should see that your bandwidth is cut in half. All right, can you, let's see what's going on here with the curl statement. Okay, you got a space in there. That's the problem. Yep. There you go. Yeah. All right, what kind of, how many megabytes per second did you get? It'll be in the far right-hand side, like right here. 111. Okay. If we look at that 111, and I go over and I bring up a calculator, the calculator right there, and I type that 111 times 8, and you can see that we're getting 888 megabits per second right there. 888. Okay? That's 111 megabytes. And we're just going to do bit to bits, and that gives us the times 8, and that's, of course, 888. Now, I'm going to go ahead and I'm going to say, expect that you're going to get about 90% efficiency or 88% efficiency on our next system. Expect 88% efficiency. Let's go ahead and calculate how long it's going to take to download this file. There's your file. It's a 1.25 gig file, which if we take that and convert it to megabytes, it's 1,230 megabytes, okay? If you want the time, go ahead and make the units the same. So we take that file, which is 1,230 megabytes, or 1.2 gig, right? So that's a pretty fair-sized file, right? There are a lot of files smaller, and there are a lot of files bigger, but 1.2 gig. And so if you look at that 1.2 gig file, and you say, all right, I need to convert that to instead of that 1,230 megabyte file, I want to convert it to a megabit file. What do you multiply it by? How many bits in a byte? 8. There you go. So over here, 4 bits is a nibble. Anybody? Yeah, isn't that weird? Okay. So over there we got this 1230 times 8 gives us 9840 megabits. Okay? 9840 megabits. So if you know you're getting 880 megabits per second, 88% efficiency on a gigabit network, how many seconds should it take you to download that file? Do the calculation. All right. Yep, so a lot of you getting that. So right over there, you've got the 9840 megabits. You divide that by 880 right there. So I'm going to bring up a calculator. And we'll just do it right here. So 9840 divided by 880 equals 11.18. All right, so that's about 11 seconds is what we're looking at. 11.1 seconds, well, 11 seconds and 0.18 is like, I don't know, 11 point something seconds. It's 11.18 seconds, there you go. So that right there is about 11 seconds to download the file. Okay, I'm going to test that right now on this FTP site. I'm going to download this file, and I'm going to see how close we were. So we're going to download that thing, and we'll see how close we are to this. Now I'm going to do a curl. In this case, it's an FTP site. So I've got this FTP file, and I'm going to pipe that out to dev null, just like that.